the PASCObot Sense and Control Kit is not a kid's toy. It's a highly engineered, engaging tool for teaching coding and physics and maybe some math too, depending on what your purposes are. I've got two of them here. This one we'll get to later. This one is outfitted with the gripper and also has the rangefinder on it. But I'm just going to use the basic bot with the control node for this first example. And what we're going to do is tell the bot to move in a precise way. So first we need to connect it to SparkView. And so on the bottom here is a power button. And now I've got the Bluetooth activated. And over here with SparkView, and again we could use Capstone as well. I'm going to connect to the control node, which is the brain of the PASCObot. And the first thing I see are all these things I could get data from. I can get the angle and angular velocity, position and velocity of each of the stepper motors on the wheels. I can get the distance from the rangefinder, and I can get the acceleration from the built-in accelerometer and the servo current. In this case, I'm going to pick the position and velocity of the left stepper motor because that'll give me positive values when it's going forward, which seems to make sense. And I'll uncheck everything else here. And let's make a graph. And we'll come back to this graph later because before we can get it to graph anything, we need to tell it what to do. So I click on the code window, and the stepper motor block is here in the hardware menu. And that is a powerful tool for telling the stepper motor everything you need it to. But it'd be better to bring in a function that's already built to use that block. So I'm going to bring in from the Pasco code library, move a distance. And so that will move the PASCObot the distance I put here, in this case in centimeters. And so this is calling this function. So I'll put that function out of the way here. If I want more of those, they now appear in the function menu. So I can pull them out if I want and have it move any number of distances. Then it'd be also good if we could get it to turn, and you can have it do curve turns or just a quick 90-degree turn. I'm going to do that and bring in the turn left or right function from the library. So there's the left and the turn right functions. And what I'm going to do is have it go in a rectangle. And so I have to picture which way is that going to go. It's going to turn right. I'm going to have it go clockwise. So I can do that. I can pull more. Now notice the turn right and left show up here. So I can pull more of them out. Or I can do a right click and duplicate whatever blocks I want. And that makes things go pretty fast too. And let's have it turn right at the end too. So it's kind of back where it started. And then I need to tell it how far to go. So I worked out ahead of time that with this table I can get it to go that far. And again, we want to duplicate this math block. And we'll have it go 35 on the short side. And one more here. You can put in any dimensions you want. I'm limited by the table. And then notice this turn left is still here. It's going to execute that. So I could delete it, and I can always pull another one, or you can disable blocks that you might want to use later. And so I have it ready to go, but let's go back to the display window. So I just click on the, it's like a toggle button, right? It goes between the code window and the graph window. And let's see what it does. Hopefully what it did in rehearsal. No. I just don't have faith in it, but it doesn't go on. And look at the graph of position and velocity. I'm getting a whole lot of questions when I look at that. So if you want students to understand and learn kinematics with the PASCObot, this is a perfect tool, as well as physics. Now that was successful, but that isn't where the learning occurs. The learning occurs when you're trying to do things and it doesn't work. And with coding, a lot of times that's just, oh, the code doesn't run. But to me, it's much more engaging when you see it do something you didn't expect from your code. You immediately want to open the code and see, why did it do that? What can I learn from that? How can I become a better coder? And so that's the experience your students will have over and over again. Another thing I wanted to show is the line follower. This one is outfitted with the line follower. And I'm going to use a feature that's in here. If I go back to the code window, another option for running the code is I can upload it directly to the control node using these buttons up here. And so I've already done that for the line follower program, and that's a good thing for the line follower program because it can react faster and it works better if I do that. Also, I can have, this is a pretty neat trick, I can have the code on the computer turning on and off the code that's already uploaded to the control node. Once I realized you could do that, the possibilities for what you can do with the line follower and other things just exploded. So when I turn this on and then hit the button again, it's going to run the code that I already uploaded. And it's following the line using 4 infrared lights that shine down, and then we measure with 4 sensors the reflected light. And so beforehand, I had to tell it how much reflection comes off the white tape, how much comes off the table, and it then is able to try and keep the tape in the center of those sensors as it goes. And then as a little extra, I programmed it so that it would turn around when it runs into a line of tape that's crosswise. In other words, all 4 sensors measure the tape rather than just in the middle. So once students start playing with this, again, not playing, working, learning, they're going to want to come up with way cooler things than this. I'm kind of, again, limited here at the kids' table. Now, we mentioned there was a built-in accelerometer in here, and so I also put in the code a function that will, a command that will turn it off if the accelerometer measures that it's been tipped up. There. So that's kind of a great thing to do without having to turn it off. You can just turn it off too. You can also execute it using SparkView. Well, again, we didn't use the gripper or the rangefinder with this one. Let's do that. And so in this case, I'm going to open up something I've already coded. So I made a graph of distance. And so what is the distance? Well, it's the distance from the rangefinder in front here. The rangefinder sends out pulses of infrared light and measures the time it takes it to return. Knowing the speed of light, it can figure out how far away things are. So if I hit start, it starts the program. The code is looking for when I place this cup in front of it. If I put it, well, notice the range is 0. If it's not detecting anything in front of it, it just says 0. If I put the cup here, it found the cup, but the cup's about 40 centimeters away. The code is going to start activating if I get it closer than that, about 30. There, now it finds it, picks it up, and does, well, whatever I put in the code, at least after playing around with it for a while. Oh, did you hear that? There's a speaker in it too, as we heard over there. And so you can add, a backup beeper, or in this case, a little yay, I did it message. Hopefully I've just, shown you some things that make you want to investigate this further, but we just don't have time to go through everything we could do. If only I had wouldn't I need my own webinar to go through everything with the PASCObot Sense and Control Kit? And so join us again on April 13th, and we'll go through a lot more with the PASCObot. Thanks for joining us today, and we hope you check out all of our STEMsense products on the PASCO.com website. See you next time.